So class, we have the question this: find the value of x and y by substitution method. Suppose this is equation first, this is second. So we'll write now from equation first we get 3x minus y equals to 3. This is 3. So x will be equals to 3 plus y upon 3. This will be the value of x. So now by substitution method, substituting x equals to 3 plus y upon 3. In equation second, we get, now what I am doing, I am substituting the value of x, which is from first equation, equal to 3 plus y upon 3 in equation number second. So equation number second is 9x minus 3y equals to 9. Now we will put the value of x here. 9 into, what's the value of x? X equal to 3 plus y. This is the value of x. 3 plus y upon 3 minus 3y equals to 9. So we can cancel out from 3. 9 is multiplying here. So 3 ones are 3. 3 times 9. Okay. Now we can write this like this to denote this our steps. Now 3 is multiplying to 3 plus y minus 3y equals to 9. This will be equals to 3 into 3 will be equals to 9 plus 3y minus 3y equals to 9. So now you are looking, here is the condition becomes, the condition is here, after putting the value of x is 3y is cancelling from 3y, 9 equals to 9. That means x and y does not have any certain solution. Does not have any specific solution. Specific. So here x and y have many solutions and also both equations are equivalent to each other. We can also write this, okay, both linear equations are equivalent to each other. Also we can verify the statement algebraically. This statement is very true, but I am also showing you, I'm also going to show you algebraically what are the equations. Equations are this: 3x minus y equal to 3, 9x minus 3y equal to 9. So from this equation, if I compare this equation with a1x plus b1y equals to c1, a2x plus b2y equals to c2, therefore a1 will be equals to 3 and b1 will be equals to minus 1, a2 will be equals to 9 and b2 will be equals to minus 3. Now a1 by a2 equals to 3 upon 9 which will be equal to 1 upon 3. Okay, and from here b1 by b2 equals to minus 1 upon minus 3, which is also equals to 1 upon 3. And if I compare c1 is equals to 3 and c2 is equals to 9. So c1 upon c2 equals to 3 upon 9, which is equals to 1 upon 3. So c1 by c2 equal to 1 by 3. One second. a1 by a2 1 by 3, b1 by b2 1 by 3. So here we can write this algebraically. It will be, as I wrote this, and both linear equations are equivalent to each other. That means a1 by a2 equals to b1 by b2 equals to c1 by c2. And if you represent this equation graphically, it will be like this. Equation number A will be like this, first equation will be like this, and second equation will lie upon this. So this is, we call this equation coincident. That's why it does not have any specific solution, because on every point, on each point, they both are satisfying. Every point they are satisfying. So they are coincident as well as they are consistent, because they are dependent. Consistent, or we can say they are dependent. Dependent to each other. Class. So you will face in your board examination these kind of questions so much. So you have to determine whether the LHS is equal to RHS or not. Here in this case, LHS is clearly equal to RHS after substituting the value. 1 second. Here RHS equals to RHS. So we concluded two things: X and Y have many solutions, X and Y does not have any specific solution. Both linear equations are equivalent to each other. That means algebraically a2 equals to b1 by b2 equals to c1 by c2, and graphically they both are coincident. This is your first line and this is your second line, line number 2, and this is your line number 1. Okay, so if you want to keep watching videos like this, so please subscribe the channel.